Now on to our final honorary degree. I would like to announce or present Cheryl Blanchard presenting our honorary degree to our commencement speaker, Dr. Langer. Cheryl is a 1986 graduate of ceramic engineering. Cheryl went on to get her PhD in material science and engineering from the University of Texas. Cheryl is currently the CEO of publicly traded Anika Therapeutics. Unfortunately, but Alfred is outside of ordinary, Cheryl's going to be presenting Dr. Langer via an audio recording because Cheryl is back in Boston recovering from cancer treatments. So I want to thank Cheryl for knowing and introducing Dr. Langer to us and being able to present him with an honorary degree today. So the hooding of Dr. Langer will be from Terry Mahalski and Chris Heckel.
Mr. President, students, staff, faculty, and guests, I am pleased to present to you Dr. Robert S. Langer, professor in the Massachusetts Institute of Technology Departments of Chemical Engineering and Biological Engineering. As a faculty member in the David H. Koch Institute of Integrative Cancer Research, he is one of 12 institute professors at MIT. Being an institute professor is the highest honor that can be awarded to an MIT faculty member. Dr. Langer is world-renowned for his contributions to medicine and biotechnology. He is viewed as the founder of the field of tissue engineering in regenerative medicine and is the pioneer of hundreds of technologies, including controlled release and transdermal drug delivery systems, which allow for the non-invasive administration of drugs through the skin. He holds more than 1,400 granted or pending patents, which have been licensed or sub-licensed to more than 400 companies. He is the author of more than 1,500 articles, and with more than 363,000 citations, he is the most cited engineer in history and fourth most cited individual in any field of academic research. Dr. Langer is also a prolific entrepreneur, having participated in the founding of more than 40 biotechnology companies, including Cambridge, Massachusetts-based COVID-19 vaccine maker Moderna, which pioneered messenger RNA therapies and vaccines. Dr. Langer is the recipient of more than 220 awards and is one of just 3 living individuals who have received both the United States National Medal of Science in 2006 and the United States National Medal of Technology and Innovation in 2011. He is also a recipient of the Charles Stark Draper Prize, considered the equivalent of the Nobel Prize for Engineers, the Queen Elizabeth Prize for Engineering, Albany Medical Center Prize, Breakthrough Prize in Life Sciences, Kyoto Prize, Wolf Prize for Chemistry, Millennial Technology Prize, Priestley Medal, the highest award of the American Chemical Society, Gardner Prize, Hoover Medal, Dreyfus Prize in Chemical Sciences, and the BBVA Frontiers of Knowledge Award in Biomedicine. Dr. Langer earned his bachelor's degree in chemical engineering from Cornell University and his doctoral degree also in chemical engineering from MIT. He is the recipient of 36 honorary degrees and has been elected to the National Academy of Sciences, the National Academy of Engineering, National Academy of Medicine, and National Academy of Inventors. Mr. President, I am honored to present Dr. Robert S. Langer for the conferral of the degree Doctor of Science, honoris causa, in recognition of his many significant accomplishments as a scientist, researcher, and entrepreneur.
Cheryl, thank you for that wonderful introduction. We know you're watching by live stream from Winchester, Mass. Know that we're thinking of you. Cheryl herself is a member of the National Academy of Engineering. Dr. Robert S. Langer, in recognition of your accomplishments and by virtue of the authority vested in me by Alfred University's Board of Trustees, I confer upon you the Doctor of Science honoris causa, with all the rights, privileges, and responsibilities thereto appertaining. And in token whereof, I cause you to be vested with the hood of the degree and instruct that your status be charged in the membership roll of the Alfred University Alumni Association. Congratulations, and I'd have to say it now 37 times, but doctor, with one of those doctors being an Alfred University doctor.
I'm waiting for my instructions.
Now I would like to provide a short introduction to our honorary degree recipient before we turn the mic over to him. I've known of Dr. Langer for most of my 36-year career, but it has only been the last 10 years that I've had the great pleasure to know Bob as a person and to have the absolute privilege to work with him. It is truly an honor for us all to have him here today as our commencement speaker. You heard me call out Bob's terribly impressive accomplishments that he is so deserving of, but let me just take a minute to set the stage for the person you're about to meet. When you walk into Bob's office, you literally can't see the walls of his office, and he's starting to lose room with stacks on the floor of all of the awards and prizes he has earned. That long list of patents I mentioned, well, they've been licensed to over 400 companies that have turned those inventions into medical products and drugs that have saved or improved the lives of over 2 billion people. That's 40 companies Bob has founded or co-founded, including Moderna, that little Boston startup that's been saving the world here lately. Well, he co-founded another company called Microchip's Biotech. That was where Bob, as co-founder and board member, hired me into my first CEO job. How lucky was I? But enough of that, because I could go on. Here's what I really want you to know about Bob. He is a genuinely nice person who mentors and helps other people succeed. And pay attention here, all the new graduates. I am convinced that has been the secret to his unparalleled success. These are traits I have truly come to value after 36 years in corporate life. Don't get me wrong, Bob works tirelessly, demands great work, and answers to the toughest of questions from his students and companies. But that is just the entry card to his success, not his secret. When Bob graduated from MIT with his doctorate in chemical engineering, all of his friends took the easy path to super high-paying jobs at one of the oil companies. Instead, Bob pursued a path of continued rejection, uncertainty, and low-paying jobs. For a while. I mean, he seems to be doing okay these days. But he followed that difficult path, never giving up, to get a position where he could work in the medical field and help people. And while he wouldn't tell you this, at the end of the day, he forged his own path by developing a couple of new fields that have changed the face of medicine: tissue engineering, the basis for the successful field of regenerative medicine, and drug delivery, the enabling science for delivering drugs like mRNA therapies that simply didn't work without lipid nanoparticles, for example. He has spent his life teaching, inventing, mentoring, and helping populations of people feel better, get better, and do better. So without further ado, Dr. Robert Langer.
Thank you. Well, thank you so much, Dr. Blanchard. Cheryl Blanchard, who's a member of your board of trustees, she's a role model for the whole world. I also want to thank Dr. Edmondson, the Alfred University Board of Trustees, and the students of this terrific university. I actually know this is a terrific university firsthand because my sister Kathy went here and graduated in 1982, and she told me that. I feel very privileged to speak to you this morning, and I want to congratulate all of you and also all your families. Congratulations. I also want to leave you with some simple messages that kind of mirror what Dr. Blanchard said. First, when you choose a job as you leave here, follow your passion. Choose something that you think you'll really love. Don't do something just for the money. Do it for what you really care about. And then try to dream big dreams, dreams that you hope can change the world and make it a better place. Also, you know, when you do things like this, and whatever you do, I'm sure you're going to run into roadblocks. Everybody does. And no matter how bad things look, I hope you don't give up. And fourth, treat everyone with kindness, I just think, and respect. I just think that's so important for everyone. I thought I'd expand a little bit on what Dr. Blanchard said and use myself as an example of struggles, but also dreams. So I got my degree in chemical engineering in 1974. There was a gas shortage then, like a few years ago. But in 1974, it was really bad. Like if you were in Boston and you had a car, you actually had to wait in line 2 hours to get your tank filled up. But if you were a chemical engineer, that was actually really good because you got lots of job offers. So all my classmates pretty much went to work at oil companies. So I thought I'd do the same thing. You know, they had lots of openings, super high-paying jobs. And it turned out I got 20 job offers from oil companies. I wasn't that good. Actually, four of those offers were from Exxon alone. One of them made quite an impression on me. I remember going to one of these places, one of these Exxons, this was in Louisiana, and they said, gee, if you could increase the yield of this one chemical by 0.1%, they said that would be fantastic. It would be worth billions of dollars. I remember flying back home to Boston that night thinking to myself that I really didn't want to do that. And it made me think more about what I did want to do. And I've always had this dream, even at that age, in my 20s, of using my background to improve people's lives. When I was a graduate student, and I was supposed to be doing my thesis, I helped start a school for poor high school kids. And I got very involved in creating new math and chemistry curricula. And one day I saw an ad to do just that at City College of New York. So I wrote them a letter applying for a job, but they didn't write me back. But I really liked that idea, so I found all the ads I could to do that, about 40 of them. I wrote to all of them, and actually none of those 40 wrote me back. So that wasn't going so well. So I started to think, what other way could I use my chemical engineering background to help people? So I thought about health-related research. So I applied to a lot of hospitals and medical schools. They didn't write me back either. Then one day I walked into the lab where I was, and one of the older scientists said to me, he said, Bob, you know, there's this surgeon named Dr. Judah Folkman at Boston Children's Hospital and Harvard. And he said, sometimes he hires unusual people. And he was kind enough to offer me a job. So I took, at that time, what seemed like a high risk to all my friends, and I began doing research in a hospital. I was actually the only engineer in the entire hospital. I began working on two projects. They were kind of related. One was trying to discover the first substances that could stop cancer blood vessels from growing, and hopefully that stopped tumor growth. And secondly, as Dr. Blanchard mentioned, developing tiny particles, nanoparticles or microparticles, that might be able to deliver these substances that I was trying to find, and really any large molecular weight substances, such as proteins or RNA, to the body. Before I worked on this problem, no one had been able to do this, and in fact, every scientist that we talked to told us this was impossible. I didn't really listen to them. I spent 2 years working on this, and actually I found over 200 different ways to get this to not work. But finally, I discovered some ways where I could modify certain materials, make them into tiny particles, and get it to work. And I use these particles to create ways of studying how different substances might affect cancer. And we actually found the first substance that could stop blood vessels. As an aside, and this is often how medicine works, it took 28 years from the paper we wrote, which was in the journal Science in 1976 on this, until the FDA approved the first blood vessel inhibitor. Today, such inhibitors called Avastin, Lucentis, and Eylea are some of the most widely used biopharmaceuticals for treating cancer and eye diseases like macular degeneration and diabetic retinopathy. They've been used by millions of patients. You know, about 2 years after I started working on this drug delivery project, I remember being asked to give a lecture to a very distinguished audience of scientists at a conference in Michigan. I was 27 years old. I'd never given a big talk before. But by the time the talk was over, I felt better. I didn't forget too much what I was going to say. I didn't stammer too much. So I thought when I was done with this talk that all these older scientists being nice people, would want to encourage me, this young guy. But when I got done speaking, a number of these older scientists came up to me and they said, "We don't believe anything you just said. We know you can't get these substances through these tiny particles. They're just too big to go through the walls of those particles. It's kind of like any of us walking through a brick wall. It's impossible." Also, after that, shortly after that talk, I tried to get funding to support my research. My first 9 grants were rejected. And when I was done with my work doing this blood vessel and drug delivery work, I applied for faculty positions in chemical engineering departments. That's my background. Not a single one would offer me a job. So I ended up actually in a nutrition department. But the year after I got that department, the chairman who hired me, and he was kind of like a benevolent dictator kind of person, he offered me the job, but he didn't bother to ask anybody else in the faculty what they thought. So unfortunately, the year after I joined the department, he left. So pretty much everybody else in the department told me I should leave too. I'm still there though. But you know, and one more challenge was getting a patent. You know, we filed a patent with the patent office, and 5 years in a row, the patent examiner rejected it. And so the people at the hospital and MIT, they said I should just give up. But you can probably tell by now, I don't believe in giving up. So I started thinking about how to get, you know, new ways of getting the patent allowed, legally, of course. And the patent examiner actually didn't really understand it because he said it might be obvious. But as I told you before, in the beginning, everybody said this was impossible, it couldn't work. So I wondered, maybe somebody wrote that down. So I actually analyzed the literature. You know, we had published a paper in the journal Nature in 1976. This is now 1982 after 5 years of rejection. And I found a paper by 5 famous scientists saying that Dr. Folkman, who I mentioned, and myself have reported some surprising results that clearly demonstrate the opposite of what scientists had said before. So I showed this to the examiner, and he said, "Gee, I will actually now allow the patent if you can get written affidavits from each of these people that they really wrote that." So I wrote them, and they were nice enough to write me back that they really wrote it. And this would lead to new treatments by companies we started and licensed things to treat schizophrenia, alcoholism, opioid addiction, diabetes, cancer, and many other diseases. Over the years, my students and I, we've started something like, as Cheryl mentioned, 40 companies. So just to tell you briefly about one of them she mentioned, which is Moderna. In 2010, myself and 3 others started this company to develop messenger RNA therapeutics and vaccines. And again, as she mentioned, these molecules had to be delivered in nanoparticles, made using many of the principles our lab had developed over the years. Otherwise, the RNA would be destroyed. Again, even now, after we started the company, many people in the scientific community, stock analysts and the press criticized both me and the company. They said these approaches would never work. For example, and this is even 2 years ago, when we started developing vaccines to treat COVID, the Boston Globe, that's my hometown newspaper, they ran a front page article in May of 2020 as we were in clinical trials. And the title of the front page headline is, "This is not how you do science." And they put my picture right underneath it. It's always good to have a nice hometown newspaper. But Moderna and its terrific employees, some of whom are my former students, never gave up. Today, the Moderna vaccine and one somewhat like it made by Pfizer and BioNTech, also using nanoparticles, are used by billions of people all over the world. This leads me to my final point. Many ask me about people in our lab and that they've done quite well. And I like to think it's because we've treated everyone with respect and kindness, treating people the way you hope they would treat you. No matter, so my last piece of advice, and maybe most important, is no matter what you do with your life career-wise, there's nothing more important than being a good, caring, kind human being. I want to conclude by saying how deeply honored I am to receive this honorary degree. And most importantly, I want to congratulate all of you and your families on this very special day of your lives. Thank you so very, very much. Thank you. Thank you. Thank you. Thank you.